Hey class, this video is to help you learn about two proportion z-tests. The goal of this video is to have you understand what a p-value is, to understand what an alpha is. By the end of the video you should see a couple examples of how to write a two proportion z-test and just some calculator tutorials. So here we go. So quick review of what we're doing here. We're doing a two proportion z-test. So what we're doing in any kind of test is we're trying to see how far does your test statistic, if the null hypothesis were true and the parameter really was the number down the middle, what's the likelihood of that test statistic occurring? And that test statistic is going to occur based on your random sample. So if you get a really small, so according to the definition, sorry I'm bouncing all over the place, but the definition says the p-value is defined as the probability, so that's what you're finding with the z-score, of obtaining a result equal to or more extreme. So you're trying to find the z-score of this, the probability that this will occur, or more extreme. And then the same thing if we were doing a less than, when the null hypothesis is true. So if this is truly the parameter and you find some random sample and you calculate the z-score and you get a really small probability, that means that this sample is so unlikely to occur that this cannot be truly the parameter. So the null hypothesis must be false. So if we state that p equals something and the alternative is, I don't know, in this case greater than, what you're stating, what the p-value is stating, is that whatever you saw in your random sample is so unlikely to happen that this can't be the parameter. And if this can't be the parameter, the null hypothesis can't be true. And so the p-value is going to tell us the likelihood of whatever we saw in our random sample occurring, given that this is really, the null is actually true. All right? So we said, what's likely or unlikely to happen? Well, everybody's description of what's likely or unlikely might be different. So we set a level called the significance level, and that's alpha. The significance level is the probability that, the significance level is the null hypothesis is rejected if the value is less than this predetermined level. Typically our level is 5%. So we're just setting a level that states anything below this alpha is unlikely to occur. So depending on the situation, your alpha may be 1%, maybe 10%, depending on the issue or how conservative you need to be, but typically we do 5%. And that's just a number that states anything below 5% is unlikely to occur. All right, so let's try an example. Males and females were asked about what they would do if they received a $100 bill by mail addressed to their neighbor but wrongly delivered to them. Would they return it to their neighbor? Of the 69 men sampled, 52 said yes. And of the 131 females sampled, 120 said yes. So as I'm reading, I'm also just making notes so that way when I'm ready to actually do the problem, I'm ready to go. So does this data indicate that the proportions that said yes are different? That's important. For male and female at a 5% significance level. Okay, so this word different, there's our claim. That's what you're trying to prove. So does the data indicate the proportion that said yes are different? Doesn't say less than, doesn't say greater than, just says different. So that means we're going to try to prove that it's not equal to. And then here we have our alpha is 5%. All right. So to start off this problem, we're going to do the state part of the problem where we state the parameters and the hypotheses. So in this part of the problem, we're going to label the different parameters. And this time we have two of them. So we're going to label, we'll just say the men first just because they appeared first in the question. The true proportion of men willing to return the money. And P2 is the true proportion of women. So that's how this problem is different. Willing to return the money. All right, so we've got our null hypothesis, we've got our alternative hypothesis, and we're going to try to prove that they're different. The null hypothesis is the hypothesis that the parameter has not changed. It is whatever is stated. And the alternative is your claim. So if we believe that there's no change or no effect between the two groups, we're essentially saying that we don't expect these to be different. So I believe the rate that they return the money is the same. However, we're trying to prove that they are different. So we're going to try to prove the true proportion of men is not equal to the true proportion of women willing to return the money. And we are going to try this at a 5% significance level. So let's see what happens. Okay, so that's the state part of the problem. Now we're ready to look at the conditions. So we're going to plan this problem out. Okay, in order to plan a problem out, we need to make sure it's a random sample. We need to make sure that the distributions are approximately normal, so that way we can use our z-scores. And we need to check to make sure that the population is large enough that we're getting independent samples. Unfortunately, it did not say that the samples were selected at random. Just for the sake of this problem, we're going to pretend it is because we haven't done one without that stipulation yet. So let's just pretend that it did say the people chosen at random. Okay, so done. Now we need to check if the distribution is approximately normal. Well, we've got two distributions now, so we have to check both. Okay, this one's the men, this one's the women. So for the men, we've got, remember, you should be stopping the video and trying these on your own and then checking in with me. Don't just sit there and watch the video. You need to be trying and practicing, okay? So that works. That works. So the men is approximately normal. Now let's check out the women. We got 120 over 131. And 131 times 11 over 131. All right. And that, we're left with 120. We're left with 11. And the females work too. So I'm just going to make one blanket statement. Distributions are approximately normal. Okay, and let's see if our population and our samples work. So we're looking to see that there are 690 men out there in the world that get mail, and then 131 times 10 is 1,310 females that would get mail, and I'm positive that that works. So population at least 10 times the sample. So our plan here is to use a 2 proportion z-test. All right. So let's do that 2 proportion z-test. It's a little complicated. Well, not too complicated. You guys are pretty smart, so we'll figure this out. The formula is p hat 1 minus p hat 2 over p hat times 1 minus p hat times 1 over n1 plus 1 over n2. All right, so we've got all these different p hats. So let's go through and make sure we understand that they are before we get started. P hat 1 is the sample proportion of men who would return the money, and that would be 52 out of 69, and we said that that's 75. P hat 2 is the sample proportion of women willing to return the money, and that is 120 over 131, which is about 93%. Okay, then we've got p hat. What's that? Well, that's how many people were willing to return the money regardless of their gender. So we're looking at anybody that's willing to return the money. So that would be 52 men and 120 women over 69 men plus 131 women. So that's 172 out of 200, and that's 0.86, okay? So let's just review. This is the sample proportion of men who would return the money, the sample proportion of women who would return the money, and then sample proportion of people willing to return the money. Okay, so now that you've got all these numbers, we're ready to substitute into here. So we're going to do 75 minus 93 over 86 times 14, that's the complement, times the first sample size plus the second sample size. Okay, and when you do that, you get negative 3.14, and we're ready to look that up. Almost ready. Gotta draw this first. Gotta wow you. Oh, look at how ugly that is. Sorry. All right, negative 314 would be like, remember this should have been an asymptote, so like right here. And remember that this is a not equal to problem. Remember at the beginning of the problem, we said we're trying to prove this. So what we're trying to prove here is maybe it got smaller, maybe it got bigger. We don't really know what's happening to the proportions. We're going to do a two-sided test here. So we're going to test positive 314 and negative 314. Okay, so I'm going to look this up in my booklet. And when I look this up in my booklet, I get 0.0008. Because of symmetry, these have to be the same. But I could also look that up in my booklet too. So the p-value is 0.008 plus 0.008, which is 0.016. That's a pretty small p-value, so I think we're okay here. We're going to reject H0. That means the null cannot be true because the probability of getting these sample sizes is so small, given that that was true, that it's unlikely to occur. So we're going to reject the null hypothesis out of here. So that means we're left with this hypothesis, which is what we wanted. So now we're ready to conclude. Obviously, you can't be like, you're out of here. You got to like write it nicely. So we're going to write it right now. I do, or you could be nice and say, we do have significant evidence at alpha equals 0.5. You're going to write parameter 1, that the true proportion of men willing to return the money is different. Now you're going to write parameter 2. Then the true proportion of women willing to return the money. All right, so that's how you write a two proportion Z test. Okay, let's look at, well, what if were doing a less than or greater than hypothesis test? How would we look up the p-value there? So if we were doing a less than problem, you would just go over here to 314, negative 314, shade to the left. There's really nothing to shade because we're already in the asymptotes. Look that number up, and it's 0.008. So in this case, the p-value would be 0.008. Okay, if we were doing a greater than problem, so that's for less than. If we're doing a greater than problem, we'd go to our z-score, which would be out here. 14, sorry. Ooh, it's pi, I didn't even notice that. Okay, so we're doing a greater than problem. Remember the arrow kind of gives you a hint of which way you're shading. That one we're going to shade that way. That one we're going to shade that way. So, okay, I can look this portion up in my book and I get 0.008. So to get this pink portion here, I'm going to do 1 minus 0.008. And so the p-value would be, oh, I could have done that in my head, duh. Sorry. The p-value is going to be really large. Okay, so let's really quick do, let me show you how to do it on your calculator, and then I'll let you go. So you're going to go to Stat, then you're going to go to Test, and what we're doing today is called a two proportion z-test. Okay, and then here you're going to enter in the data that you collected. So 52 men said they would return the money out of 69 men. 120 women said they would return the money out of 131. And we are doing a not equal to problem. So I'm going to go to calculate. And there's our z-score, our p-value, and then all the other numbers that we use to substitute into the equation. Okay, so hopefully that helps. Good luck studying for this exam and good luck with the two proportion z-test.